Welcome to Study Loop.
Okay, let's take a look at the question. So the question was asking us what is the resolution limit of the telescope and what kind of assumption did you make? Okay, let's take a look at the first question. Well, the resolution limit is basically the resolution angle, or another word, resolution degree of the telescope. And well, there's a formula for this, but let's take a look at the non-condition first. Well, we know the radius is 3 meters. So it's a 3-meter radius mirror, okay? And we don't know the wavelengths, but that's fine, since the whole point of this question is making an assumption. So we don't know the wavelength of the light hitting the mirror of the telescope, but let's assume that the wavelength is a wavelength from the middle of the spectrum, which is 550 nanometers. Okay? And you see the formula here, theta m equal to 1.22 lambda divided by d. Well, it seems like we don't know d, but actually we do, because d here means the diameter, and diameter is 2 times radius, and we know radius, right? So now the lambda is known, d is known as well, and 1.22 is just the coefficient from this formula. So let's plug in all the data and then try to figure out the answer. Okay? So we get something like this. So theta m is equal to 1.22 times 550 nanometers divided by d, which is 2r, so 2 times 3 meters, and that will just give us 1.22 times 550 times 10 to the negative 9 meters, because 1 nanometer is 10 to the negative 9 meters, and 2 times 3 meters is 6 meters, and that will give us theta m, or in other words, theta resolution is equal to 1.12 times 10 to the negative 7 radian. Okay? And remember, well, there's no significant difference between a degree and radians. The only difference is just the conversion is different. It's just like meter and nanometers, they are all measuring units, but the only difference is because of their quantity. Okay, and that's the difference between the radians and degree as well. And for such question, we can just leave the answer like this. So 1.12 times 10 to the negative 7 radian is fine for this question. And let's look at the second question. What kind of assumption we can make? Well, you can tell that the result might not be correct. It's because we made an assumption. So it might not be the exact wavelengths that we're hitting on the mirror of the telescope. Okay? So since we assume that the lambda, which is the wavelength, is 550 nanometers, well, in fact, the lambda could be larger. Okay? So the wavelength may be larger in the real case, because the wavelengths we're using is from the center of the spectrum, and wavelengths beside the center of the spectrum could be larger than the wavelengths in the middle. And that's my answers. Thank you.